All right, so we are technically starting chapter 3 today, which is going to move us into linears. So the rest of our semester, we're going to be focusing in on linear equations. So we're going to be looking at them in a variety of different ways. Hopefully, some of this chapter is review. You'll remember how to have solved for y and graph and some things like that. So as we start today, let's go ahead and take a look at solving to slope-intercept form and standard form today, because we need to be able to manipulate the literal equation very, very well when we're solving equations for linears, because we need different forms for different purposes. Okay, so slope-intercept form is really used for graphing. So that's your y equals. And we're also going to be looking at standard form today, which is used to find x and y intercepts, which is what we will be talking about tomorrow. So to start with, let's go ahead and take a minute and see if you can figure out the patterns in the table. And we're going to go ahead and pull slope from this table to see, kind of start bringing that into the mix. So go ahead and see what you can do with that. And I'll catch up here in just a second. All right, let's see what you came up with. So the pattern of the y's, if I notice, this is going down. So since it's decreasing, I know that that is negative. So from 10 to 7, 7 to 4, that is all negative 3. And this is consistent. Okay, if it's consistent, a consistent pattern, I know that I'm looking at probably a linear, at least on that side. Now let's take a look over here. From 1 to 3, 3 to 5, this is plus 2, and so is this. Okay, so is that. So I know that since these are both consistent and they're adding or subtracting, then I know we're looking at a linear function. Now, what I need you to remember is that when we have a linear function, we have slope. And slope is labeled with the letter m. Okay, and it is also the change in y over the change in x. And when we're talking about the change, that's what this triangle means. The change is actually these numbers. It's the pattern, okay? So it's the pattern of y over the pattern of x. So in this case, the slope would be a negative 3 over 2. So every time I move, I'm going to shift down 3 and right 2. Okay, down 3 and right 2. So that kind of gives me my motion when I'm drawing my line. Okay, so let's take a look at a little bit of vocabulary today to start with. So a linear equation is any equation that forms a line. Okay, any equation that forms a line. And remember, a line is straight. So you don't have to say that when somebody says, well, what can you tell me about this line? If I was to draw a line like this, obviously that's straight. So you don't want to say anything about being straight. It's a line. Okay. The first thing we need to write down is our standard form of equations. So let's write this equation down, this linear equation, ax plus by equals c. This is called standard form of the linear equation. Okay, standard form. And the key to standard form is it has absolutely no fractions. Okay, it can have absolutely no fractions. We have to clear the fractions. And a, b, and c are actually numbers. Okay, a, b, and c are actually numbers. We'll take a look at that a little bit more as we kind of keep moving here. And linear equations are going to have 2 or less variables. Okay, 2 or less variables. And there can be no powers because a line is one-dimensional. The variables are not multiplied or divided, and the variables cannot be denominators. So those are the 4 things we're looking for. So 2 or less variables, and it doesn't necessarily have to be x and y. It could be m and n. They can't have any powers. The variables are not multiplied or divided, and the variables cannot be denominators, which means they cannot be on the bottom of a fraction. Okay, so make sure that you've taken some pretty good notes on this slide, that you especially have this standard form of the equation written down because you're going to need that formula. And then let's take a look here at these functions and decide whether or not they are linear. Okay, so just as a review, we said that 2 or less variables. Okay, and we also said no powers, no multiply or divide, and no variables on denominator. Okay, so those were our 4 pieces. So let's take a look at what we've got here. Let's take a look at this first one. So y equals 2x plus 5. That one has 2 or less variables. There's no powers. It's not multiplying or dividing, and there is no denominator that's a variable. So this one is linear. Okay, as a matter of fact, that is in y equals mx plus b form, which is really important. If I look at the second one, what do I see right there? That is a power, and it says we can have no powers. So that one is a no. It is not linear. Let's take a look at the next one. 3xy plus 2. Well, that might be an issue. There's an x and a y, and those are multiplied. And we said it can't be multiplied. So this one is a no. That one is also not linear. Okay, now let's look at this one. 3n equals 2m minus 8. Well, it's not x and y. Is that a problem? Does it matter if the variables are different? No, it doesn't. I can make a linear equation by using any 2 variables. Okay, any 2 or less variables. So that one is fine. This one is linear. Okay, it is linear. Okay, take a look at these last 3. Make a decision whether or not you think these are linear or not. Okay, let's go ahead and start with which ones are not linear. Okay, which ones are not linear? Hopefully you crossed this one out and you said that is not linear because there is a variable in the denominator. We cannot have a variable on the bottom. Okay, variables have to be on top. They cannot be on the bottom. These 2 are linear. Okay, these 2 are linear. This one, okay, this one can be solved to x equals. And since it can be solved to x equals, that gives me 2 or less variables. And this one is x equals 5. Okay, so I want to pull you back to what type of line this is. So x equals 5, there's x equals 5 right there. That line is a vertical line at 5. So these 2 are actually vertical. So those are linear. So if I gave you a y equals 2, that one would also be linear. Okay, that one would also be linear. So one variable works as long as I can solve that equation to be x equals or y equals. All right, so hopefully that makes some sense on what a linear equation looks like. Now, the goal of today is to be able to move back and forth between standard form and slope-intercept form. Okay, so remember, standard form is ax plus by equals c. And the only rule was there can't be any fractions. Okay, there cannot be any fractions. And x has to come first. So if I take a look at this y equals 3x minus 5, it's pretty close. I notice that the x needs to go this direction. So to move the x, I would subtract it. So I have negative 3x, and remember, that happens to be a positive 1y that's there, and I still have my negative 5. So now, do I have x's, y's, and then a number? Yes, I do, okay? And sometimes I will even see this in one more way. They might say a has to be positive, okay? So I might have to multiply all of this by a negative 1, which is the best answer you can possibly get, and I come up with 3x minus y equals 5, which means a is 3, because that's my a, b is negative 1, and c is 5. Okay, c is 5. Okay, let's take a look at the next problem. So the next problem has a fraction. So I could move this 2/3 over, but then I just moved the fraction from one side to the other. So when I have a fraction, I'm going to clear fractions, and hopefully you remember how we did that. Remember, we needed to have a least common denominator. Well, in this case, there's only one denominator, which happens to be a 3. So I'm going to multiply every piece by 3. So this gives me a 3y. Now here, 2 times 3 is 6. 6 divided by 3 is going to take me back to 2. So these really go away. And then minus 24. So I am super close to having the correct answer. I just need to move my x. So moving my x, I'm going to subtract. So minus 2x plus 3y equals a negative 24. Now I can go ahead and write down these numbers, but it's really not the best answer. Okay, it's really not the best answer. We really want a to be positive. So if I multiply that by a negative 1, the best answer for a is positive 2. Best answer for B is negative 3, and the best answer for C is positive 24. So that would be your best answers for A, B, and C. Let's go ahead and try one of these on your own. So go ahead and hit pause and see what you can do with this. Okay, let's see how you did. So remember, you're clearing fractions. So my common denominator is 7, so I'm going to multiply everything by 7. So 7y equals negative 2x, because those are going to go away, minus 56. The negative 2x needs to move, so 2x plus 7y equals 56, which leaves me with A equaling 2, B equals 7, and C equals 56. So if that's what you got, good job. All right, now we're actually going to move the other direction. And we practiced some of these when we were doing literals in chapter 2, where we were solving those variable equations to other variable equations. So we are going to start in standard form, and we're going to go to slope-intercept form. Now, slope-intercept form is probably the most helpful form we have for graphing. Okay, it tells us the slope. Remember, the m is the slope, and the b is the y-intercept. Okay, so the most powerful form of linear is slope-intercept, because we can go any direction from there. We can graph, we can find parallels, we can find perpendiculars. It's definitely the most powerful. Okay, so we need to be able to take any equation, any linear equation, and solve it to y equals. So if I take a look at this one and I'm solving for y, I'm sure that you guys can almost do this in your head, but I'm going to go ahead and write this out. So times negative 2 would be the first thing that's happening to y, divided by negative 2, and then the positive 3x would become a negative 3x. So the first thing I'm going to do is subtract my x. Remember, that's going to go away. So negative 2y is equal to negative 3x plus 15. Now, to move the negative 2, I know I'm dividing, and I'm dividing everything. Okay, I'm dividing everything. So here's where we have to be a little bit aware of what's going on with our problem, because we want some fractions when we are working on slope-intercept form, but the y-intercept can be a decimal. So the slope needs to be the fraction. The y-intercept can be the decimal. Okay, so the b, the y-intercept, is my decimal. The slope is always going to stay a fraction, because that tells me my motion. It gives me my rise over run. So negative 3 divided by negative 2 is going to give me 3/2. That's positive. So watch your sign. And 15 divided by negative 2 is negative 7.5. Okay, negative 7.5. And just to kind of review real quick on what that would look like. So here's my graph. And I'm starting at negative 7.5. So 1, 2, 3, 4, 5, 6, 7.5. I'm starting right here. That's my first point. That's what this B is. Okay, that B is the beginning. And this tells me since it's positive, I'm going to go up and I'm going to go right. So 1, 2, 3, and 1, 2. And I can do it again. 1, 2, 3, 1, 2. My line, that's a pretty bad line, is going this way. Okay. We'll do a little bit more review of the graphing, but that should kind of link back to what you learned last year in terms of graphing. Okay. All right. So why don't you go ahead and see what you can do with this next one. Keep in mind the order of the variables there and hit pause. See if you can solve for y. All right. Let's see what you did. Okay. So the y is what we're solving for. So that one stays. No matter where it is, it's going to stay. So this time it's subtracting 5x, so I'm adding 5x. So I have 6y equals 5x plus 30. Dividing by 6, 1, 2, 3 times. So y equals 5 over 6x plus 30 divided by 6 is 5. This is my slope, and that is my y-intercept. So if I was graphing that one, I'm starting at 5, positive 5 on the y-axis. I'm going to go up 5 more. 1, 2, 3, 4, 5, and I'm going right 6. 1, 2, 3, 4, 5, 6. And there is that line. Okay, so sometimes we'll see linears that have even more operators in it. So if you take a look at this last one, it's got parentheses and extra numbers, and we need to still solve for y. So why don't you take a minute and see what you can do with this one. All right, let's see how you did. So the first thing we should notice is that there's a distributive property here. So we're going to go ahead and distribute. So 6x plus 18. And then remember, I'm solving for y, so this needs to stay. So I'm moving the 5. So 2y equals 6x plus 23. And I'm dividing by 2. 1, 2, 3. So y equals 6 divided by 2 is 3. And remember, that's technically 3 over 1. Okay, that's technically 3 over 1, but 3x works. And half of 23, okay, half of 23, we can leave this as 23 over 2. That works, okay? We can definitely do that, but I want you to think about where's 23 over 2 on this line? How do you graph that? Okay, how do you graph that? So for those of us who maybe don't remember how to get that decimal or do that on the calculator, so 23 divided by 2, everybody should remember how to do that. That's 11.5, okay? So it would make more sense for me to write that as 11.5 because 11.5 I can find on the y-axis. Okay, I can find that on the y-axis. It's pretty hard for me to, if I don't know what 23 over 2 is in my head, to know where I'm going to start that graph. All right, so that is what you're working on for today. Focusing on going from standard form to slope-intercept form and back and forth. So remember to clear those fractions, and we will catch up with you tomorrow. Make sure you come in with questions.